Hey guys, today we are going to solve a problem that's been, it's not a huge problem, but it's irritating. So this is my tool holders drawer for the lathe, and it's not like a huge mess or anything, but it is annoying because the tool holders just slide around and they don't stay in either direction. So we've got them moving around all the time, and anyway, it's just a minor annoyance that I've been thinking about for a while, and time to do something about it in a pretty cheap way that I think is going to work out just totally fine. This is just going to handle my turning and small boring bar holders, so I've still got to do something about my chucks and live centers. Right now they're just in cardboard boxes that they came in or other parts came in. So we'll think of something there. Be a great application for a 3D printer, but I do not own one. So let me show you what we're gonna do. Here I've got a little prototype that I made the other night with just some materials I had sitting around. So this is a piece of 3/8 inch thick flat bar, 3 inches wide. This is just a drop that I have in my steel drawer. And just drilled a couple of holes, reamed them out for the gauge or the dowel pins to sit in, and that's about the right configuration for holding a CA, Aloris CA size tool post, or tool holder rather. So fits on there pretty snug, but there is some clearance, so it's not like you have to line it up, 100% perfect to get it to go on there. So this is going to be a fairly inexpensive project. I already had this piece of flat bar sitting in the cabinet over there, a couple of packs of dowel pins. It's not expensive. So we need to cut this to length, decide what our spacing is going to be between the tool holders, and then go over to the milling machine to drill and ream some holes. And for that part, I'm going to share something I've done a little bit differently this time compared to what I normally would. This is kind of the typical thing you would use. A letter U drill, and this is a 1/1000th undersized reamer. The 1018 cold rolled flat bar is fairly gummy and fairly soft, so I wanted to go a full 1/1000th undersize for pressing those dowel pins in there. It's not going to be like a hard press or anything, but I just think over a little bit of wear, a 1/2 thou or smaller undersized reamer is going to, or closer to exact size, the dowel pins are going to get loose and then I'd have to mess with them. So anyway, that's my idea. This is just a standard high-speed steel letter U drill. And what I decided to do, just for fun and a little bit of learning, was to get a carbide drill. And so there's a lot of different carbide drills out there. Some of them have, special coating. Some of them, obviously, there's through coolant type. There's some that just do different things different ways. And this one is a Kennametal GoDrill. And this is a line that they designed for micro drilling. So this goes all the way down to I think 37 thousandths they make these in. And its idea here is to make an economical drill that is basically disposable. It's cheap enough that you don't need to regrind it to get your value out of it. And one of the ways they do that is pretty neat, something that I didn't realize until talking to a buddy of mine the other day. But the way they make these so cheap is that it has less grinding on it. So if you compare it to this letter U high-speed drill, the margin is kind of this edge here that goes all the way up to the cutting edge. And they did not grind that in the GoDrills. So what does that do? Well, that margin is what helps keep your hole, the drill straight in the hole. So as you make the hole with the tip, that basically follows that hole size, so your holes end up staying closer to the exact drill size. If you're going to process the hole again, either with threads or reaming, or you've got counterbores to do or whatever, this is a great kind of drill to use. They're not very expensive, like I said. This one is letter U, obviously. I went with the same diameter as this one. These are made in Germany. It's got a tin coating on them. So you can, easily see wear on them. They've got a 140-degree point. It does have a little bit of a different style of chisel point. So anyway, I sell these through my day job, and they're pretty popular with CNC customers. So I figured it would be fun to use one on this little project where I've got a bunch of holes to use, and just get some experience. It's not necessary. I would very easily get through with a high-speed drill, but doing new things is why I'm out here in the garage. So let me do some measurements on my flat bar and figure out where we want all of our holes, and then we'll take the bar over to the milling machine and start making our dowel pin holes. Here's our setup. I've just got the flat bar in the vise, and then my Moore tool blocks supporting it in 4 places with just toe clamps on the ends. So all the pressure is going to be downward, so I'm not too worried about stability. Another thing I didn't mention is because of this drill being carbide, there's really no benefit in spot drilling. So we're just going to drill right through. Speeds and feeds, this guy recommends, I did the calculation earlier, but I think my RPMs need to be at about 2400, which sounds pretty fast. So we'll see how I like that. And then this drill is also designed to work just fine with minimal lubricant system. So we don't have to have flood coolant. Flood coolant would be great. They make these, like I said before, in a through coolant version, which is even better, but obviously on a manual mill, that's not an option. Whoa. We'll slow it down a little. Okay, so our next space is going to be 1" 7/30. And I'll just zero each time. Problem with carbide drills is this drill chuck can't bite into the material, into the shank of the drill at all. So I'd love to use just a collet, but these drills being made overseas use metric dimensions. So it's a 10mm collet. There's not a good way to get 10mm without buying a specific collet for it to use metric. But the quality of the hole is really nice. I don't know how visible that's going to be on the video, but we do have a nice surface finish on the inside of that. So I slowed it down. I didn't even get it all the way up to 2400. So that was at 1800 to start with, and now I'm down to about 1650. Yeah, 1650, 1675, something like that. So anyway, I think feed pressure is going to be a little bit of a touch and go, or touch and see how I can feel it out. But otherwise, should work out. Yeah, everything turned out pretty nice. So we'll go ahead and get my checking reamer, and I think I can put it in a collet. I think it's got a 3/8 shank. And then we will ream our holes to size. As you would expect, the drill's in good shape. All right, we're down to about 700 RPM, and the recommended feed rate is 10 thou per rev, so gonna go slowly, but I'm not gonna mess with power feeding down. So there we go. That Kennametal drill did pretty well, I think. There's some of the twisty chips that it made. Obviously couldn't run it fast enough, but anyway, I think it turned out pretty nice. So the drill was good, and the reamer seemed to do really nice as well. So why don't we test and put a couple of dowel pins in, maybe 2 sets of these, and then we will just kind of see how it fits in the drawer. There's one more to be made for my parting blade. It sits out, comes out the side of the tool holder quite a bit. So I wanted to get these done, put a tool holder in this last one before I decided where to make those holes. No problem. Going a little further, and that's exactly what I was hoping for. It's nice and snug on my sample piece here. I used a different reamer. It was 375 reamer, so there's not, it's just kind of a sliding fit. So anyway, I wanted something a little tighter, and that's exactly what we got. Okay, instead of these guys just moving all over the place in the drawer, that's what we're looking for. So you can see there's just a little bit of movement in both directions. Again, these are CA size holders, 3/8 inch dowel pins, and they are 2 inches on center. So if you've got the same setup and you want to try something like this, that's what I did. But yeah, that's pretty good. let's go put this in the drawer. So that should work out pretty well. Okay, so I'm just gonna put a couple of pins in on our last one that we've made so far. Just by finger tight here. I don't want them in the way when I'm drilling the last couple of holes. But the reason these holes are a little bit, spaced wider this way is to allow these tool holders. So these extended length have a narrower spot for the tool to be held. And so the tool sticks out and makes them a little wider. And then our little parting blade block should fit in there kind of like that. Yeah, it looks all right. So if we're going to guesstimate our distance from the center of the pin to the end of the plate is about, we'll say 700. Eyeball is going to be way good enough. Looks all right. I think that's a pretty good fit. The tool holders shouldn't, interfere with the front of the drawer very much, if at all. Don't want this whole thing right up against it, because then coming up, this lip will be in the way. But I think that's probably pretty good right there. And so I think what I'm going to do, in order to keep this whole thing from moving around, we've got these nice perforated holes in the bottom of the drawer. So I'm just going to mark with a Sharpie on the underside on the bottom of my little plate in a couple of spots, and then I'll just drill and tap for like 1032. I think we'll fit through there. Maybe not. Maybe need 824, 832, and that'll just suck this thing down a little bit. It doesn't need to be super stuck on there, but just to keep it from sliding back and forth under the drawer closing. So yeah, that's going to work out, I think. All loaded up and fastened to the bottom of the drawer, so there's going to be no sliding around or anything. I think that'll work. So these are hardened, and up against the hardened tool blocks, there's potential for some wear, but not with as much as I'm out here running the lathe. So I'm not too worried about that. I'll probably make some sort of a system so that these guys do go back in the same spot every time, just so I can build up some muscle memory or whatever to grab the right tool kind of without looking. So I do need to make another one of some design, so it can go in here. If I can even leave this drawer the same dimensions and just put a strip basically in the back and have the pins in it for boring bars like that, or pull this guy out and move it forward, or take it out completely and line up some more, who knows. Wouldn't be bad to also have the chucks and live centers, closer to me, so I don't have to open the drawer all the way. And then the least used turning tools and boring tools in the back. So we'll see how it goes, but I think that's a successful little project, fairly cheap. I just had to buy the dowel pins and the reamer. I decided to buy the reamer. I could have gone without, or just used the other reamer I had. And then of course I bought the drill because I wanted to experiment with that solid carbide. So anyway, hopefully that inspired someone to come up with something even better. I'm sure some of you noticed this, some of this stuff in the background here. So I ordered some fine thread 1/2-inch set screws to replace these guys. So these studs that come with the Aloris holders, that slot in them makes them pretty rough. I can lap those threads, but then I've still got old worn out screws in there. So anyway, I'm gonna replace those, pretty cheap to do. Also, some of them are pretty chewed up. There's no telling how old some of these are. So I bought some, got some new appropriate length set screws for replacing these guys. And then this thing, just wanted some feedback from you guys. So a long time ago, I thought of, man, it'd be really nice to have a 4-jaw chuck on the tailstock, and that way I can kind of run things, you know, almost like running between centers, but, you know, 2 4-jaw chucks so that it's running perfectly true on both ends, and decided, hey, let's go ahead and do that. I saw Curtis's implementation of that on Cutting Edge Engineering Australia. Curtis is a real machinist. You go check him out if you're not watching him already. But he's got one that he designed, and it worked out really well. So that inspired me even more to like, okay, how can I do this? So I've just got a 6-inch 4-jaw chuck here, nothing special about it. It's an import Chinese one, plain back, obviously. And what I bought was a 4 Morse taper, Jacobs taper number 5, I think is what that is. Yeah, Jacobs taper number 5. So the idea here is I can turn this off to a diameter that will fit the inside of bearings. So this is what I'm thinking, and I want your feedback on what the best way to do this is. I was going to machine a plate, not too thick, and then have my bearings, you know, mounted in that plate on one end, and then turn this down to the ID of the bearings, press this guy in there, and of course mount my plate on the back of the chuck just like so. I want to try and minimize the amount of weight I add. There's not, you know, the tailstock spindle barrel is huge, so I'm not really worried about damaging anything, but I don't want to have extra weight on there that I don't need. This guy's already fairly heavy, so don't want to go too nuts on adding a whole bunch of material. But if you have any ideas for me that are better than what I just suggested, or bearing sizes that would be good, I'm planning on using a pair of tapered roller bearings in opposite directions. That's, from my understanding, that's the way to go for axial and thrust loads like this. But anyway, so there's some ideas. I even thought about, hey, maybe I bore out the back of this for the OD of one of the bearings, and then the backing plate will hold the other bearing OD. So those are just my ideas. I'm open and happy to get some better ideas, but figured those of you that watched the entire video would be able to offer some good advice. Thanks very much, and we will see you again next time.